So good afternoon, everyone. My name is Amit Kumar Pal, and I'll be starting with a chapter of the determinant that we had left on the last session. So I think we had covered almost everything, and we were on the topic linear equation in form of the matrices, and we were trying to solve those questions. So okay, so I think we had covered almost yeah, so we were on this topic, linear equation in form of the matrices, and we had also checked the condition for the existence of the solution. We had checked the condition like any system of the equation of the form of m cross n, m equations and n unknowns. Okay, so we had seen that we can represent the system in the form of ax plus b, and then we concluded that we can solve it by multiplying with a inverse on the both the side, right? So a inverse times a into x equals to a inverse b. Okay, and we had seen that this becomes identity, and this is equal to x equals to a inverse b. Okay, and we had also concluded that this is equal to 1 by determinant of a times adjoint of a and b. Okay, and depending on the condition of the determinant, we concluded that if determinant is non-zero, then we get a unique solution, but in case our determinant is 0. Okay, so depending on the condition of adjoint of a, whether the adjoint of A is 0 or whether the adjoint of A is non-zero, we had infinite many solution or we had no solution case, right? So yeah, we had covered that case, and basically we'll be solving questions now, and we'll be checking how to uh, how to utilize our understanding of the concepts, right? So let's say we see the question here. Okay, so for instance, let's say we take the question number 4. Okay, so this says that x plus y plus z equal to 1 and 2x plus 3y plus 2z equal to 2, and this is ax plus ay plus 2az equal to 4. Okay, so we are given these three questions and we have to solve this system of equation. All right, so what we can do, we can represent this system in form of matrix. Let's say 1 2, this is a, and this is 1 3, this is a, this is 1 2 and 2a times, and here we can write x, y, z, and this is equal to 1 2 4. Okay, so we can say this is our system of the equation, and if we solve the system now, so everything depends on the condition of the determinant. Okay, so we have this matrix, so if we find the determinant of this matrix, okay, so its determinant is equal to 1 into 6a minus 2a minus 1 into 4a minus 2a plus this is 1 into 2 2a minus 3a. Okay, so we quickly find the determinant. So this is equal to 4a minus 2a plus minus a. Okay, so this is equal to a. Okay, so this is our final case, and depending on the condition of a. Okay, what is the condition of a? Okay, whether our a is 0 or non-zero. Okay, so if we carefully see, if a is non-zero, okay, a is not equal to 0, then clearly there exists a unique solution. Okay, but if a equal to 0, so if you observe carefully, this cannot be the case, because if our a is equal to 0, then this equation would be 0 equal to 4. Okay, so not possible. Okay, this is not possible. Okay, so our a can only be non-zero. All right, so since our A is non-zero, so we can say that the system, our given system is consistent. All right. So this can concluded about this part. Okay. So similarly, So in the remaining question also you have to see the same case whether the determinant is zero or non-zero. Like I had given you the intuition about first one question. So similarly, like for every other question, you have to check like here also, like in some cases the terms of x are not present. Okay, so like in this equation, like in this question, the term of x is not present. Okay, so you can assume the x to be equal to 0. Okay, so for those equation whose x term is not present or y term is not present, so you can simply consider that these coefficients are 0. Okay, so like in this way you can form the matrix and check for the consistency of the solution. Okay, and now if we try to solve the questions, okay, solve the equations. So let's say we take our question number. So let's say our question number 11. Okay. So we are given again the system of the equation. So this is 2x minus y equal to minus 2, and this is equal to 3x plus 4 y is equal to uh, so this is not a question number 11 actually. So our question number 11 is 2x minus plus y plus z equal to 1, and this is x minus 2y minus z equal to 3y2, and this is 3y minus 5z equal to 9. Okay, so you can consider this is 0x plus 3y minus 5z equal to 0. Okay, and if we now try to solve this equation, so we can first form the matrix. Okay, so let's quickly form our matrix. So uh, this is 2, this is 1, this is 0, and this is 1 minus 2, this is 3, and this is 1 minus 1 minus 5, and now there are variable matrix, and this is equal to 1 3 by 2, and this is 9. Okay, तो अगेन इसमें हम पहले चेक करेंगे कि डिटर्मिनेंट की कंडीशन फुलफिल हो रही है या नहीं. ओके, so firstly you need to find the determinant whether the determinant is zero or non-zero. Okay, so if we expand along the first row, so our determinant is 2 times uh, 10 plus 3, this is minus 1 times minus 5, and plus 1 times of 3. Okay, so finally our determinant comes out to be equal to 10 plus 3 13 into 2 then 26 plus 5 equals to 31 plus 3 34. Okay, so this is 34 and this is non-zero. Okay, so our delta is non-zero. Okay, so we can say that a unique solution exists in this case. Okay, so now for the solution, we know that the solution is given by 1 by determinant of A times the adjoint of A into matrix B. Okay, this is our solution matrix. Okay, so we'll first find the determinant matrix once again. Okay, like we'll find the adjoint matrix. Okay, so quickly let's calculate the cofactor matrix. Okay, so let us see our cofactor matrix. So uh, this would be 13, this would be 5, and this would be 3, and this would be what 3 minus 5 minus 3. Okay, so this would be 8, and this would be minus 10, and this would be minus 6, and let's say this would be our 1, and this would be 3, and this would be minus 5. Okay, so we'll take now transpose of this matrix. So transpose would be 3 13 8 and this would be 1, this would be 5, and this would be minus 10, and this would be 3, and this would be 3 minus 6 minus 5. Okay, and so this is adjoint of A. Okay, so this is adjoint of A matrix. So now our unknown matrix should be 1 by 34 times 13, 5, 3, and this should be 8 minus 10 minus 6, 1, 3 minus 5 into matrix B. Okay. So what was our matrix B? So this was 1, 3 by 2, and this would be 9. Okay. So now if we quickly multiply these two matrix, so our unknown matrix would be 1 by 34, and so we will multiply these two matrix. So we already know how the multiplication is performed, like this row will be multiplied by this column to give this entry. Okay, so this would be 13 plus 3 by 2 into 8 plus 9. Okay, so this would be 34, and this would be 17, this would be minus 51. Okay, and there is a division of 1 by 34, so this would be 1, this would be 1 by 2, and this would be minus 3 by 2. Okay, so our final matrix, that is x, y, z, this would be simply equal to 1, 1 by 2, and minus 3 by 2. So this is finally our solution matrix, and this is how we get the solution for this problem. Okay, so this is our final solution, and if we now move to our next part, let's say uh, we pick another question. Let's say, so let's say we take question number 14. Okay, so our question number 14 is x minus y plus 2z equal to 7, and this is our 3x plus 4y minus 5z, this is equal to minus 5, and this is 2x minus y plus 3z equal to 12. Okay, so we just have to perform the same thing, that is our matrix would be like this type. This would be 1, 3, and this would be 2, this would be minus 1, 4, minus 1, and this would be 2, minus 5, 3 times of x, y, z, and this is equal to 7. This would be 7 minus 5, and this would be 12. Okay, so if we quickly find the determinant of this matrix, so this would be 1 into uh, 12 minus 5, this would be plus 1 into 9 plus 10, and this would be plus 2 of minus 3 minus 8. Okay, so this should be simply 7 plus 19 minus 22. Okay, so this should be 4. Okay, so again our delta is not equal to 0, so we can say that our inverse matrix. Okay, so our inverse matrix should be 1 by determinant of A times adjoint of A. Okay, so this should be simply, if we find the adjoint matrix, so adjoint matrix, firstly let's calculate the cofactor matrix. So our cofactor matrix should be, this would be 7, this would be minus 19, and this should be minus 11, and this would be 1, minus 1, minus 1, and this would be minus 3, 11, and 7. Okay, so finally our transpose matrix, that is adjoint matrix, so this would be 7, 1, minus 3, and this would be 19, minus 1, 11, and this would be minus 11, minus 1, and 7. Okay, so our inverse matrix should be 1 by determinant of A times adjoint of A. Okay, so this would be 1 by 4 times 7 minus 19 minus 11, 1 minus 1 minus 1, and this would be minus 3, 11, and 7. Okay, and apart from that you have to multiply the matrix of B. Okay, so this would be finally your x Y and Z. Okay. So finally, let's quickly multiply. So this would be 49 minus 5 minus 36. Okay. And this term would be minus 133 plus 5 plus 132, and this would be minus 77 plus 5 plus 84. Okay. So finally, this is x, y, z, and this would be equal to 1 by 4 of, so this term would be simply equal to 8, and this should be, this is minus 133. Okay. So this should be 4, and this should be our 12. Okay. So our final matrix should be, this should be 2, this should be 1, and this should be 3. Okay. So this is our final answer, that is xyz equal to 2 and 3. Okay. So that's all about this question, and like we have solved two questions about equation solving, and for the remaining questions also, like you have to just find the determinant at first, and after that you have to approach your question. Okay. So like if we take one theoretical question, that is question number 16. So about question number 16, some theoretical description is given to us, like basically you are given the cost of 4 kg onion, 3 kg wheat, and 2 kg rice is 60, and similarly, like for different conditions you are given the cost. Okay. So you have to find the cost of each item using the matrix method. Okay. So we can assume, let's say, the cost of onion and cost of and cost of rice. This is equal to z. Okay. So according to first condition, we are given that 4 kg onion cost. Okay. 4x plus 3y plus 2z equal to 60, and 2x plus 4y, and this is equal to 90, and the cost of 6 kg onion, so 6x plus 2y plus, okay, so xyz are basically the cost per kg, and for the different condition you are given the weight, and you are given cost, so you have to formulate the equation at first. Okay. So you have to solve this equation, and of course, like firstly you have to check the condition of the determinant. So we can make the matrix quickly. Let's say this is 4 2 6, and this is 3 4 2, and this is 2 6 3, and this is x y z, and this is equal to, okay, so you are given this. Okay. And now if we find the determinant, so if the determinant would be 4 times of 12 minus 12, and this would be minus 3 times 6 minus 36, and this would be plus 2 times 4 minus 24. Okay. So this would be 0 plus 90 minus 40. Okay. So this would be 50. Okay. So finally this is not equal to 0, so we can say that our delta is not equal to 0, so unique solution exists. Okay. Since unique solution exists, so we can also find those unique solution. Okay. So all you have to do is you have to find the cofactor matrix. Okay. So firstly let's go find the uh, C matrices. So C matrix is basically our cofactor matrix. So this would be 0, and this would be 30, and this would be minus 20. This would be minus 5, 0, 10. This would be 10 minus 20, and this would be 10. Okay. So our adjoint matrix would be the transpose of this matrix. So this would be 0 minus 5 this should be 10, and this should be 30, 0, minus 20, and this should be minus 20, 10, and this should be again 10. Okay. Now our solution matrix would be x equal to 1 by determinant A times adjoint matrix. So this should be 0, 30, minus 20, minus 5, 0, 10, and this should be 10, minus 20, and this should be 10. Okay. And there was B matrix as well. So B matrix was 60, 90, and this should be 70. Okay. So this should be 1 by 4 into, determinant was 50. Okay. So this should be 50 times. So this should be 250. Okay. And this should be 400, and this should be also 400. Okay. So this would simply equal to 588. Okay. So you can say per kg prices are given by this matrix. Okay, 588. Okay. So the price of wheat is like price of onion is 5 rupees per kg, and price of rice and wheat is 8 rupees per kg. Okay. So that's all about this question, and so from this we have concluded our exercise part, and now we have some miscellaneous exercise. So like miscellaneous has some good questions actually. So definitely this should be a lot of learning. So we can quickly see our miscellaneous exercise as well, and this should be actually good practice of understanding of concepts. So we'll be trying this exercise now. So from here now you have to basically more apply more properties of determinant rather than just simply expanding them. Okay. Because you might see some determinants are quite weird and lengthy one actually if you directly expand them. So it's better to recall all the properties at first rather than just simply expanding them from the beginning. Okay. What I mean is, let's say we see question number 1. Okay. So this is x sine theta, and this is cos theta minus of sine. This is sine theta, and this is minus x1, and this is cos theta 1, and this is x. Okay. So you have to show that this determinant is independent of theta. Okay. So the approach is simply like you have to expand this determinant, and in the end you have to prove that this determinant is independent of theta. Okay, so let's quickly find our determinant. So this becomes equal to x into minus x square minus 1. This is minus sine theta of minus x sine theta minus cos theta, and this is plus of cos theta of minus sine theta plus x cos theta. Okay. So if you quickly find the determinant, so this is a minus x cube, this is minus x, and so if you see this term and this term, so these two terms are opposite of each other, and similarly like if you see this terms and this terms. Okay. So these two terms basically cancel each other, and this is if you take x common from both the terms, so this is sine square theta plus cos square theta. Okay. So this is a minus x cube minus x plus x. Okay. So this simply equal to sorry. So this is minus x cube simply. Okay. So you can see this term is simply independent of theta. Okay. So you have to prove the same thing, and we have also obtained the result. Okay. So if we move to our next question, that is question number 2. So you have to evaluate this determinant. So this is cos alpha, cos beta, and this is cos alpha sin beta. This is minus sin alpha, and this is minus sin beta, and cos beta 0, sin alpha sin beta, and this is sin alpha sin beta. This is cos alpha. Okay. So you are given this matrix and you have to just find the determinant of this matrix. Okay. So about this question, so one thing you can do is a direct expansion, or if you think you can apply some properties, so you can move with this approach. But right now, I think I don't get any idea about the properties. So let's try to expand it directly without thinking much about a property. So this is cos alpha cos beta, and in the bracket there will be cos alpha cos beta again. So this will be cos alpha cos beta minus 0. Okay, and now this would be minus of cos alpha cos beta cos alpha sin beta of minus of cos alpha sin beta minus 0, and this will be minus sin alpha. Okay, so this would be our expansion, and now if we think, so this would be cos square alpha cos square beta, and this would be our plus of cos square alpha sin square beta, and this would be our minus plus of sin square alpha sin square beta, and this should be our sin square alpha sin square beta. Okay, so these would be our terms, and if we take cos square alpha common from this two brackets, so we'll be finally left with only cos square alpha, because the bracket in the bracket there will be sin square alpha plus cos square beta plus sin square beta. So this would be 1. Okay, so this would be cos square alpha plus, and similarly from these two brackets this should be actually cos square beta. So from these two bracket also, if you take sin square alpha common, so this would be sin square alpha, and this would simply becomes equal to 1. Okay, and now these two terms again adds up to equal to 1 from the trigonometric properties. Okay, so that's all about this question, and now if we move to question number 3. So question number 3 is basically you are given two matrices. Let's say there is a inverse is given, and you have to find AB inverse. Okay, so you know that AB whole inverse is equal to B inverse A inverse. Okay, and now you are already given A inverse, so you can, you have two ways. So basically you can solve from this way also, but this might be a bit tedious. Uh, Actually, both the method would be equally, but I think this approach would be easier actually. From this approach, you'll have to find A matrix first. Okay, you are already given B matrix, so you have to find A matrix. So how will you find A matrix? Okay, you will simply inverse this matrix. Okay, you'll inverse A matrix. So inverse of A inverse would be again A matrix. Okay, so A inverse would be A matrix. So from here you can calculate A matrix, and then you can multiply with B, and you will get a single matrix after multiplication, and उसके बाद आप उसका इनवर्स फाइंड आउट कर सकते हो. तो वो एक मेथड है, बट वो थोड़ा लेंथी हो जाएगा, सो इस मेथड को देखते हैं. So this would be B inverse and A inverse. Okay, and since you are already given A inverse, so you have to just find B inverse. Okay, so B inverse is simply equal to B of inverse. Okay, so you have to find the inverse of B. Okay, so that we quickly find our this matrix should be 1 minus 1 and 0, and this should be 2 3 minus 2, and this should be minus 2 0 1. Okay. So this is given our B matrix, and so if we quickly find about the determinant, so if the determinant would be 1 into 3 minus 2 of this should be minus 1, and this should be minus 2 of this should be 2 minus 0. Okay, so this is 3 plus 2 plus minus 2. Okay, so this is finally 3. Okay, so this is non-zero. This is a non-zero, so we know that inverse exists, and for the inverse we just need to find the C matrix. So C matrix would be simply this should be 3, and this should be minus 1, and this should be 2, and this term would be this should be 2, and the middle term would be 1, and this should again be equal to 2, and this term would be 6, and this would be minus 2. No, this should be plus 2. Okay, and so this would be 5. Okay, so we just have to take the transpose of this method. So Ct would be equal to 3 minus 1, this would be 2, and this would be 2 1 2, and 6 2 5. Okay, so now we'll multiply with determinant. So 1 by 3 of 3 minus 1 2 2 1 2, and this would be 6 2 5. Okay, so you have finally got B inverse matrix, and you also A inverse is already given. So finally you can multiply this B inverse and A inverse, and this would be finally your AB of inverse whole matrix. Okay, so that's all about this question. Okay, in the fourth question also, like you have to just verify the properties of the matrix, and you just have to find different adjoint matrices. Like in the first case you have to find adjoint of A, and you have to take the inverse. Okay, so I'll tell you one new, actually it's actually some concept here. So you know the property, like you know the property A into adjoint of A times of A. Okay, you know that A into adjoint of A is determinant A times of identity matrix. Okay, so from here we had derived that A and 1 by determinant A times of adjoint of A is identity matrix. Okay, so from here we concluded that the inverse of this matrix is this matrix. Okay, and if we modify this result a bit, so this is equal to 1 by determinant A times A into adjoint of A. Okay, so now if we consider this matrix as some B matrix, and this should be something like A dash matrix, so we know that this A dash into B is equal to identity matrix. Okay, so we can say that inverse of this matrix is simply this matrix. So what do we mean here is that the inverse of adjoint of A, this is equal to 1 by determinant A times of A matrix. Okay, so this is actually a result, and like we know that A inverse is equal to 1 by determinant A times of adjoint of A, and similarly adjoint of A inverse is equal to 1 by determinant A times of A matrix. Okay, so this is actually some result actually you have to remember in this question, and you can verify the result using the same. Okay, so that was a little concept part that I had introduced in this question, and so like actually there is a minus sign here, so this should be plus of sine square theta, and this would also be plus. Okay, so this should be 2 plus 2 sine square theta. Okay, So it is given that theta belongs to 0 to 2 pi, okay. And if theta belong to 0 to 2 pi, you know that sin theta belong to minus 1 to plus 1, okay. So we can say that sin square theta belong to 0 to 1, okay, because it can always be positive or greater than equal to 0, okay. And if this is greater than equal to 0 and less than equal to 1, so this whole expression belong to 2 plus 2, and this belong to 0 1, okay. So this whole expression belong to 2 to 4, okay. So you can say that delta belong to 2 to 4, okay. So this is about this question, and now let's quickly see the our question number 7 that we had left. So here you are given a system of equation and you have to solve those system of equation, and basically you have to solve with matrix method, okay. So if I quickly write the system of equation, so this is 2 by x, and this is 4 by x plus 6 by y plus 5 by z. This is actually minus sign, okay. And this is equal to 1, and this is 6 by x plus 9 by y, and minus 20 by z. This is equal to 2, okay. So here what you have to do is basically you have to consider 1 by x equal to u, and 1 by y equal to v, and 1 by z equal to w, okay. And if you consider this, then your final equation becomes 2u plus 3v plus 10w equal to 4, and this expression becomes 4u minus 6v plus 5 times of w equal to 1, and this is equal to 6 times of u plus 9 times of v minus 20 times of w equal to 2, okay. So these are three equations, and we have to solve these equations, okay. Then our determinant value is simply equal to 2, 4, 6, and this would be 3 minus 6, 9, and this would be our 10, 5, and minus 20, okay. So you have to find its determinant value. So this would be 2 times of 120 minus 45 minus 3 times of minus 80 minus of 30 plus 10 times of 36 plus 36, okay. So this finally our comes to delta equal to 1200, okay. And since this is non-zero, so we can say that our solution exists, and these are non-zero, okay. And if we quickly find our C matrix, okay, cofactor matrix. So our cofactor matrix is this should be simply 75, and this should be our 110, and this should be our 72, and this is 150, and minus 100, 30. This is 72, 0 minus 24, okay. Oh, sorry. This should be 0, and this should be 75, 30 minus 24, okay. So our final A inverse would be 1 by 1200 and transpose of the above C matrix, okay. So this would be 25, 110, and 72. This would be 150 minus 100, 0, and this would be 75, 30 minus 24, okay. So our UVW matrix UVW would be 1 by 1200, and this would be 75, 11072. This would be 150 minus 100, and this would be 0, and this would be 75 30, and this would be minus 24. Okay, and also you have to multiply the matrix here. So this is 4 1 2. So from here we can say that our u, v, and w are 1 by 1200, and if you multiply these two, so this becomes 74. 5 into 4 is 300 plus 150 plus 150 is 600. So this is 600, and this is 400, and this is 240. Okay, so from here we get our u equal to 1 by 2, and v equal to 1 by 3, and w equal to 1 by 5. Okay, so from here we can say x equal to 1 by u, so this is equal to 2, and y equal to 1 by 3, so this is equal to 3, 1 by v. So z equal to 1 by w, so this would be 5. Okay, so this is our final answer for this question, and that was all about miscellaneous exercise, and I think we have completed this exercise as well. There were total 9 questions, and I think we have covered all the concepts that was necessary in this chapter. So yeah, that is all about this chapter, and I don't think we are left with any more concepts here, and we have almost covered whatever was the exercise. So yeah, we'll see in the next chapter. So till then, have a good day.